Now guys, let's move on to the next question. So, the next question is, consider the decay process tau minus becomes pi minus plus nu tau in the rest frame of tau minus. The masses of tau minus, pi minus and nu tau are m tau, m pi and 0 respectively. The energy of pi minus is m tau square minus m pi square c square by 2 m tau square plus m pi square c square by 2 m tau minus m pi c square and root of m tau m pi c square. Now, this is the given question. If you are attempting this question in the proper fashion, in how you should be attempting a subjective exam, then you're doomed to be wasting a lot of your time, which is not what we want to do in an objective competitive exam. So we know that one of these is the answer, and we are going to find out the answer from this given option by applying some special conditions to the question. Even if you apply some special conditions to our question on our own accord, still one of the options should still be valid. Since one of the options is the answer, it should still hold. Now that is the principle that we are going to use. We know that in this question, m tau, that is tau minus splits and becomes pi minus and nu tau. Alright. Say, for instance, if tau minus split and became pi minus and nu, and this nu does not take away any energy. In that case, if it does not take away any energy, then the mass of this pi minus must also be equal to this tau minus. So if we apply that in here, essentially what we should get is the energy of pi minus should remain as energy of tau minus, which was m tau minus c square. I hope you understand. I'll repeat. If I consider that this nu tau does not take away any energy, nu tau is an energyless particle, that it doesn't take away any energy. We are assuming it doesn't have mass anyways, so we can also assume, we may as well assume that it doesn't take away any energy. In that case, the initial energy and final energy will be equal, and the final energy will solely be within this pi minus, and so the pi minus will have energy equal to the initial energy of tau minus, which is m pi minus square, which is equal to m tau minus c square. So let's apply that condition here. If we apply that condition here, our special condition is m tau equal to m pi, right? So I am applying that for the option A. What does option A becomes? Option A becomes 0. That is not right. We said that if we apply that, what should happen in the end is the energy must be equal to m tau square, m tau c square, right? Let's put that in option B. What does option B give you? If we put that in option B becomes m tau square plus m tau square by 2m tau c square, which is equal to m tau c square. So option B can be an answer. We are not yet certain. Option B can be an answer. Now let's check option C. If you check option C, it becomes 0 again. Option D However, when you put that condition into option D, it becomes m2 c square. So we now know that either option B or D is the answer. Now let's look at the question once again. The question tells you that tau minus becomes pi minus plus mu tau, and m tau, m pi and 0 are the masses respectively. So I have the liberty to assume that pi is also something that can have mass 0. See, m pi is a variable. So I have the liberty to assign a special value for the variable. And I assume that m pi is 0. Then in that case, the energy of this tau minus will be equally divided between this new tau and pi minus, because both have mass 0 and everything else is basically same. So the energy must symmetrically be divided equally between both. So if m pi equal to 0, essentially what we must understand from this is that if m pi equal to 0, then the energy of pi minus should become equal to half of the energy of tau minus. So let's put that condition in. We know that it's not a, or it's not C. Now for this condition, let's put it in m pi equal to 0. Then what happens here is this becomes 0 and it will become m tau c square by 2, and d part will become equal to 0. So you know the answer. Only B, option B is the answer. Now, how to do this in the proper method? That is what we'll be discussing next. But before that, once again, I would like to tell you that if such a problem comes, put logic into the game. Use physics, because it's basically physics that we did in solving this. We didn't use much complex mathematical methods. It's physics. You know that one of the options is answer, and the option must satisfy any given condition that is a variable, and you can put it in the question. And this guy seems to mind about it, so we were able to predict the answer. Now, how to do this properly? For that, I don't think this space will be enough. I'll be rubbing it entirely. The total energy contained in the mass of m tau is equal to the energy in E tau plus E pi minus plus E of nu. This comes from the fact that energy is conserved. The next equation is E pi square equal to p square c square plus m pi square c raised to 4. Now, since energy of nu, E nu is equal to Pc, because the momentum in of both our neutrino and momentum of our pi particle is both the same. So because of that, we can write E pi square equal to, from conservation of momentum, E pi square equal to E mu square plus m pi square c raised to 4. Now if I rearrange this, I should be able to get m pi square c raised to 4 equal to E pi square minus E u square. Now we may as well divide this. Equation 1, we may divide equation 2 divided by equation 1. We'll be getting m pi square by m2 c square equal to E pi minus E mu. To arrive at equation 1 plus equation 2 implies 2E pi equal to m2 c square plus m pi square c square by m2 equal to E pi equal to m2 square plus m pi square by 2 m2. Where did I go? Now, this is our value answer for section A. So this question has a second part. The second part is asking you the velocity of pi minus. Now, if you take a look at it, you can realize that. Let's take another special case. Newton is anyways not having any mass. So if you are not assigning it any energy in the form of momentum as well, then essentially what happens is the entire energy of tau minus is passed on to pi minus, and the pi minus is not having any moment or any momentum, because tau is not having any momentum. Since tau is not having any momentum, the net momentum must be conserved, so pi minus will have the same momentum. So basically what we are telling is m2 is equal to m pi minus, and well, in this condition this guy should have velocity 0. Now let's see which of these options can account for that. If I put m2 equal to m pi minus m pi here, then we can find that option A becomes equal to 0. So option A is a viable option. Option B becomes equal to infinity. Well, velocity is nothing can attain infinite velocity if it has a mass, or if it doesn't have it. It can't attain infinite velocity. So the only possibility on the highest velocity that it can attain is c. So this is not an option. Option C implies that it would have the velocity c. Option D also tells you that it will have a velocity of c. Now we know that if like we said earlier, the entire energy is being transferred to this in the form of its own mass energy, so it will not have any velocity. So velocity of pi minus should be 0 if pi m2 equal to m pi. So this is the option. Now at this point, let us take a look at how these things work, like how we can do it in the proper channel. This is for your understanding. In my recommendation, you should never be doing this in this way during the examination, because that will not get you anything. I'll be giving you the basic formulas. So how do we work? Energy of pi minus E pi equal to we have just derived, what was it? M tau square c square by 2m tau. We know that, now we know that this energy is equal to gamma into m tau c square, which is 1 by root of 1 minus v square by c square into m tau c square. Basically, now what you have to do is you just have to rearrange it and get out your value for v from this equation, which is algebra. So you can do